Projective Geometry, Volume 1, by Oswald, Veblen, and John Wesley Young.
Chapter 7, Coordinate Systems in 2- and 3-Dimensional Forms. Section 60, Nonhomogeneous Coordinates in a Plane. Footnote: all the developments of this chapter are on the basis of assumptions A, E, and P. In order to represent the points and lines of a plane analytically, we proceed as follows. Choose any two distinct lines of the plane, which we will call the axis of coordinates, and determine on each a scale, section 48, arbitrarily, except that the point of intersection O of the lines shall be the 0 point on each scale, figure 78. This point we call the origin. Denote the fundamental points on one of the lines, which we call the x-axis, by 0x, 1x, infinity x, and on the other line, which we will call the y-axis, by 0y, 1y, infinity y. Let the line, infinity x, infinity y, be denoted by L infinity. Now let P be any point in the plane not on L infinity. Let the lines P infinity y and P infinity x meet the x-axis and the y-axis in points whose non-homogeneous coordinates are A and B respectively in the scales just established. The two numbers A, B uniquely determine and are uniquely determined by the point P. Thus, every point in the plane not on L infinity is represented by a pair of numbers, and conversely, every pair of numbers, of which one belongs to the scale of the x-axis and the other to the scale on the y-axis, determines a point in the plane, the pair of symbols infinity x, infinity y being excluded. The exceptional character of the points on L infinity will be removed presently. Section 63. By considerations similar to those used to remove the exceptional character of the point infinity in the case of the analytic treatment of the points of a line. Section 58. The two numbers just described determining the point P are called the non-homogeneous coordinates of P, with reference to the two scales on the x and the y-axis. The point P is then represented analytically by the symbol A, B. The number A is called the x-coordinate or the abscissa of the point, and is always written first in the symbol representing the point. The number B is called the y-coordinate or the ordinate of the point, and is always written last in this symbol. The plane dual of the process just described leads to the corresponding analytic representation of a line in the plane. For this purpose, choose any two distinct points in the plane, which we call the centers of coordinates, and in each the pencils of lines with these centers determine a scale arbitrarily, except that the line O joining the 2 points shall be the 0 line in each scale. This line we call the origin. Denote the fundamental lines on one of the points, which we will call the U center, by 0u, 1u, infinity u, and on the other point, which we will call the V center, by 0v, 1v, infinity v. Let the point of intersection of the lines infinity u, infinity v be denoted by P infinity, figure 79. Now let L be any line in the plane not on P infinity, and let the points L infinity v and L infinity u be on the lines of the U center and the V center, whose non-homogeneous coordinates are M and N respectively in the scales just established. The two numbers M, N uniquely determine and are uniquely determined by the line L. Thus, every line in the plane not on P infinity is represented by a pair of numbers, and conversely, every pair of numbers of which one belongs to the scale of the U center and the other to the scale of the V center determines a line in the plane, the pair of symbols infinity U, infinity V being excluded. The exceptional character of the lines on P infinity will be removed presently. The two numbers just described determining the line L are called the non-homogeneous coordinates of L with reference to the two scales on the U and V centers. The line L is then represented analytically by the symbol m, n in square brackets. The number m is called the u coordinate of the line and is always written first in the symbol just given. The number n is called the v coordinate of the line and is always written second in this symbol. A variable point of the line will frequently be represented by the symbol parentheses x, y, close paren. A variable line by the symbol square bracket u, v, close bracket. The coordinates of the point referred to two axes are called point coordinates. The coordinates of a line referred to two centers are called line coordinates. The line L infinity and the point P infinity are called the singular line and the singular point, respectively.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.